So a couple things. X and Y intercepts are fairly basic. If I want to find the X intercept, then I know Y is equal to 0, right? So just plug 0 in for Y, and you're going to get 3 over, now this problem is actually not as nice, minus 2. So now what we're going to need to do is add a 2, and actually, hold on. No. Come on. What am I doing? Come on. Sorry, my computer's not liking that. There you go. Okay. So then I add 2 on both sides, and then now what I should have is a 2. Come on. Is a 2 is equal to a 3 over 4 times a x plus 4. All right, so now we got to get the x off the denominator, so I'm going to multiply by 4 times x plus 4 on both sides. Ooh, ran out of space. Let's move that in there. Okay, and again, that's already multiplied by 2, so I can technically multiply everything by 8, right? So that's going to be a 8x plus a 8 times 4 is a 32 is equal to a 3. So, right? Yeah, yes, plus 2, 4, 8. Yep, looks good. And then you'll subtract a 32. 8x is equal to a negative 29. And divide by 8, and then x equals a negative 29 over 8. So that's the x-intercept, right? So that's a negative 29 over 8, comma, 0. Now, if I want to find the y-intercept, you just plug x equals for 0, right? So in this case, I have y equals a 3 divided by 4 times a 0 plus 4, then minus 2. So 0 plus 4 is 0. 4 times 4 is 16. So that's going to be y equals a 3 over 16 minus 2. Now that's technically over 1. So if I want to get these fractions to be the same, I'm going to multiply by 16 over 16. So y is equal to a 3 over a 16 minus a 32 over 16. 3 minus 32 is going to be a negative 29. So y equals negative 29 over a 16. All right, and that can be written as a coordinate point of 0, comma, negative 29 over 16. All right, now I am running out of little space as far as graphing and whatever else. So let's go and talk about the domain. So remember, the domain is going to be all the values that makes the denominator equal to 0. Okay, so basically what we want to do is set the denominator equal to 0 and solve. So if I want to find the domain, the only thing I know I cannot have in this domain is my denominator equals 0. So I'm going to say 4 times x plus 4 equal to 0. All right, and therefore you divide by 4. You have x plus 4 equals 0, minus 4, x equals a negative 4. So therefore, the domain is going to be all real numbers except for negative 4. And the way we can write that in interval notation is going to be negative infinity to negative 4, union negative 4 to infinity. That's a horrible infinity, but I wasn't looking at the screen. And then to find the range, which I'm like running out of space here, typically the best way is to be able to find the inverse and therefore calculate the domain from the inverse. But on this one, I know this is a rational expression where I know that there's a horizontal asymptote that is at 0 because, well, it's 0, but then it got transformed. So if you know your transformations and you know your parent graph, then you're in good shape here. You don't need to find the inverse. But if I just look at this function here, I have a horizontal asymptote at y is equal to 0. So my horizontal asymptote is at y equals 0, just for that function. Then I have my transformation of shifting it down 2. So the graph is going to be defined for all real numbers except for where the horizontal asymptote is in this example, right? Sometimes your range, sometimes you will have graphs that will pass over the horizontal asymptote. That's why it's important to find the inverse rather than just like guessing where what the horizontal asymptote is. But in this case, I know what the graph looks like and I know the transformation. So the graph does not pass the horizontal asymptote. So it's going to be all real numbers except for negative 2 because the graph was horizontal asymptote was at 0, but it got shifted down negative 2. So my range here is going to be negative infinity to negative 2. What am I doing right there? Come on. And actually, probably do. I'll probably go for a little bit longer. I'll do the giveaway at 10, but then I'll probably continue doing the math because I want to get done with these. -2 union, -2 to infinity. Voila.